Well, Chinmay has done a great job at explaining Kubernetes in layman's language. That has set a solid ground for my presentation. Thanks, Chinmay, for the great presentation over there. Yeah. So let's move forward and dive into the security aspect of Kubernetes. Good morning, all. Myself, Hardik Vyas. I work for Red Hat product security team. I basically take care of Kubernetes-based portfolio in Red Hat. More of secure software development lifecycle stuff. As you all know, Kubernetes adoption is increasing day by day. It's not just limited to IT industry, but also scaling across non-IT ecosystem like healthcare, space, automotive, you name it. So the more workload, Kubernetes workload, or the production workload that we move to the Kubernetes, the more reliant we become on Kubernetes, right? And hence it becomes more important to safeguard and secure the workload Kubernetes environment. Simple misconfiguration or maybe inadequate restrictions or safeguard measures in place could put your enterprise at risk. So in this session, we will see security best practices. Those are mostly aligned with NSA and CISA guidelines. Those security practices that we'll see that will help system administrators and developers basically mitigate the risk in the Kubernetes clusters. So the first agenda item on the list is pod and container security, where I'll walk you through how deploying and running pods, containers with least privileges possible, followed by network isolation, where controlling the amount of damage compromise can cause in worst case. Authentication and authorization again follows the same principle of least privileges. Then log auditing, where we'll see like capturing and monitoring logs so that the administrators can be alerted about any malicious activity on the systems. Last item I've intentionally kept over there is the best effort. Let me call it out. If time permits, we can quickly skim through the general security practices over there. Without any further delay, let's start our presentation with pod and container security. So by default, Kubernetes does not guarantee any workload isolation between pods running on the system. Kubernetes clusters or the nodes on the pods on the same nodes in a cluster. However, there are techniques that we can leverage to sort of, you can say, enhance the existing isolation that Kubernetes provides, right? For example, namespace. Namespace is a sort of isolation, but we are talking beyond that, right? At different, you would say, areas into the Kubernetes. So security context is one of them, the techniques or you can use security measures that we can leverage. It is one of the important player when it comes to achieving least privileges, right? The principle of least privileges. So let's take a closer look at security context. So here are a few handful of security contexts that I've mentioned. The comprehensive list of security contexts can be found in the link that I've shared below. Before I start, let me clarify a bit on security context and the pod security context that I've mentioned over there. When I say security context, they are mostly at the container level, and the pod security context, of course, at the pod spec levels, right? All in all, like most of the security context constraints are sort of similar for the pods and containers. The difference is like if a single constraint is set at both the levels, like container and pod, the one which is set at the container level will take precedence. We'll see that in the further slides where I've shown some illustration examples over there. So by default, if the developer or the image builder hasn't specifically mentioned any user in the Docker file while building the image, right? So the container by default runs as a root user, yes, with the UID of 0 over there. So it's like if your workload is not really required to run as root user, it doesn't make much sense providing that sort of privileges to the containers, right? So it's a good practice, a good hardening practice to always run the containers with, maybe you can specify a user ID that you want to run the container with, UID over there, right? Similar goes with the group ID, run as group. And the third one, which is there, that is run as non-root, which goes hands in hand. It says like if it's true, it enforces the cluster, or I would say it enforces the deployment to not run the container, right? Because it says run as non-root, which is true. Yeah, it will not allow us to run the container. Reason being, how is different than, don't get confused with the first one, which is run as user. So the run as user can also have a UID of root. That is the reason we have this third one where we enforce specifically that do not run as root, right? And user mistakenly or knowingly can also mention root user ID 0 over there. So just in case. Likewise, the privileged is something which is false by default, but if any user is enabling that, be cautious, be mindful about what you are doing. The container will be running in a privileged mode. What does that mean? The processes in the containers will be having sort of like equivalent privileges like root on the host, right? So that's what the processes will react to. And the allow privilege escalation will be disabled by default, but when we run the container in a privileged mode, it basically enables the privilege escalation as well. So you have to play with that as per your requirement. Unless and until the root access or root equivalent access is not required, I would say if the functionality that you are trying to achieve is something that can be achieved by the capabilities. Capabilities is the last one, which is something I would say very similar to the Linux capabilities provided over there, right? We just leverage it in the container subsystem here. So capabilities, let's take illustration example here. If you see the capabilities that I've shown over there, let's assume your application needs netadmin capabilities, right? So you can just enable that capabilities and drop all the other capabilities, sort of hardening. So there's a big list of capabilities over there as per your requirements. You can just dedicatedly, specifically just enable that capability over there. Now coming back to the root, I would say the run as user example that I shared in the previous slide. As you can see, the pod spec also mentions run as user, and the container also has a run as user like 3000 and 2000. So in this case, if the container has specifically declared that, okay, defined that, okay, the user should be 3000 here. So yes, that's the user ID where it will be running with. And if there is any another container in the pod hasn't declared anything or defined over there, which means it will be having the one which is defined in the pod spec, which is universal, you can say, right? And yeah, I guess I missed one point here, which is read-only file systems. So read-only file system is basically, it mounts your container file system into read-only mode. Why it is required, why it is important. Because if an attacker somehow manages to exploit or gain access to the container, he has root access to the containers, he has access to the root file system, right? He can write scripts, he can execute stuff over there, which can allow further privilege escalations going a layer beyond, right? So it's important to enable this flag. I would say just mark your root file system, container root file system as read-only. And what if my application needs to write something on the container file system, right? So in that case, you have an option, for example, it's shown below, where you can mount path, right? You can also, if it's a temporary stuff, you can just write to tempfs, temporary file system. If you want something to store, you can mount dedicated, you can create a volume over there, and you can just mount path where the application can be enabled to write stuff over there. This way, you are just restricting the application to write at specific location, giving permission to that location only, and not enabling the I would say, universal access for your root file system, right? So just going with that. Yeah. Going ahead, like protecting pod service account tokens. So by default, Kubernetes mounts the secret tokens of service accounts at the runtime in the pod, right? Why is it required? First thing, what is service account? We'll see in the first slides, next slides. So why Kubernetes mounts is by default, and why we require those secret tokens of the service accounts. And let's assume you are running some application workload on your system, and your application needs to communicate with the external world, right? So you have to enable a communication for that. You have to authenticate yourself. So if the application is supposed to authenticate with Secube API server or the external service, there is a token there on the pod. You do not have to implement any I would say fancy authentication method over there, and you can just leverage the authentication token that's already there on the pod, right? So it's auto mounted. But if the workload that you are running on the container is something that does not require this, it's go ahead and straightforward disable the auto mounting. Here's how you can do is like there is auto mount service account for service. You can set it to the false, and that's where the token will not be automatically mounted on the system, right? Set resource policies for the memories and CPU. This is very important. If not, what could be the consequences of not restricting the usage of memory, right? Yeah, this is the main purpose of restricting this is to prevent attacks like denial of services, right? What if container is compromised and the workload is breached? It's just demanding unlimited memory over there and there is no restriction in place. So assume it's consuming all the memory on your node, and at the end there is a denial DOS sort of attack. So yes, just to prevent the such sort of attacks over there, it's good to have some sort of limitations. Like for example, here you can see an example where we have defined that the request memory is 50 MB. That means for the application running the container, it requires minimum 50 MB of application. This is a hard requirement that I need 50 MB to run on the pod, and 100, which is the limit. This is the max limit. This cannot request more than 100 MB on the system. So that's how we have basically defined the limits over there. Further talking about the limits can be defined at different levels. For example, limit ranges is something that we use for defining limits for the cluster resources at the pod and container level. Likewise, at the namespace level, you can use resource quotas as well. And it's not just limited to CPU and memory. For the sake of example, we saw here the memory, right? But you can also have at the namespace level, for example, a pod is one of the resources over there that you can limit. Replicas, that is something that you can limit. So you have a sort of solid control on the resources at the namespace level as well with the resource quotas that you can explore later. And yeah, enabling SecCom and AppArmor or SLinux. Just don't get confused with SecCom and the AppArmor SLinux. Will not go into much detail into this security measures considering the time constraint. Let me just provide you a brief overview of SecCom. Is by default disabled, yes, and it basically restricts or limits the container system call capabilities, you can say, right? So you have different profiles with SecCom where you can have control over the system calls made by the containers, right? Basically, you are reducing the kernel attack surface with SecCom, just in short. Likewise, we have AppArmor and SLinux. You can choose one based on the distros you are using. So they are also restricting the application capabilities and the permissions. They provide like mandatory access control and whatnot. So that's another major security measure that you can explore on your system. In the past versions, we used to have pod security standard policies in Kubernetes, but with recent versions that is deprecated, that is no longer being used. Now we have pod security admission to enforce the security standards for the pods. So it also provides certain profiles like balance profile and whatnot, which restricts some permissions and some capabilities accordingly the profile that you choose over there. Moving to the next topic, which is network separation and hardening. So the major benefit of network segmentation here is like limiting the attack surface. We are just controlling the area of damage here. By default, Kubernetes does not provide network isolation. No network policies are applied at namespace or at pod levels, right? So you have to specifically define the network policies for your own purposes. So what's the situation when there is no network policies? That means there is no restriction on ingress or egress traffic, right, to the pods. It's open by default, which is not good practice. We want to have some sort of isolation, right? So just to prevent any damage with the compromise in case if it happens in future, right? So at the right hand side, you can see two policies snippets over there. One is egress and one is ingress. Those are deny policies. Before starting with network policies, just we have disabled both the policies, the ingress traffic and the egress traffic, right? And on the left-hand side, you can see we have just created a small sort of network policy for an application Nginx that accepts the traffic from pods. Those have label of access true, right? So the pods, those are running with the access true label. You can see the match label over there, can only communicate, or the traffic coming from such sort of labeled apps, I would say, will only be allowed for the pod that has a label of app Nginx, assuming Nginx is the application that you are running over there. So likewise, there is a dedicated communication channel that we have enabled. Any other the traffic coming from any other pods or other areas will straightforward denied due to the rules, the deny rule that we have mentioned over there. Securing the control plane and API access. So you need to lock down the control plane. Why? So let's take an example of Chinmay that he provided up to the restaurant manager, right? So what if your restaurant manager is kidnapped? Right? Who'll do scheduling? Who'll do the major tasks? Who'll entertain the customers? Where to sit? Where the job needs to be scheduled, right? So you need to lock down the access to the control plane. You need to have it's preferred or it's recommended to use a separate network for the control plane. And maybe you can also focus on the APIs. The API endpoints, those are by default open. You can harden over there. Use encrypted traffic, upgrade to TLS. So you might have applications, those are not using the TLS. Have upgrade to TLS, and it's not just important to use the TLS for the secure encrypted communication. It's also important to make sure you are using the latest releases of TLS, versions of TLS, right? Like TLS 1.3 or 1.2. The risk with the older versions of TLS like TLS 1.0 or 1.1 could be, yes, that might be suitable for the compatibility purpose of the application because it uses some ciphers. Those are still compatible with your application and you're using those since ages. But those ciphers might not be, like, they could not be no longer secure, right? So there is a risk that you are working with a weak ciphers. So just to avoid or mitigate this risk, ensure that you are on the latest versions of TLS and your application is compatible and upgraded to use the latest version of TLS for the communications, encrypted communications over there. Avoid the use of weak ciphers we already discussed. And service mesh is something which is for the advanced traffic management. It provides advanced routing. It provides better network observability. It provides mutual TLS. So what is mutual TLS? Basically the traditional TLS that we have where the client authenticates the servers, right? The client verifies the certificate from the server. But in mutual TLS, it's both way verification, I would say. Client and server both authenticate each other. They both verifies each other's certificate. So mutual TLS is something which is more secure over there. Configuring network firewall. So this is mostly at the cluster level. At the infrastructure level, you might have different layers at the architectural. So it's preferred to have the firewall as well to route the traffic accordingly, right? So let's leverage the infrastructure firewall to here. The last topic which is on this slide, which is encrypt sensitive data at rest. You might feel or it might sound like this is a bit off for this slide. Let me explain a bit on this. When I say encrypt sensitive data at rest, if your application, if you're handling some sensitive information and you are just storing it in plain text or base64 encoded stuff, whatever it is, right? And if it's traveling through the network, there's a risk to the data. And the default HTTCD key value data store that comes with Kubernetes that stores your Kubernetes secrets and the cluster state and whatnot, right? So it is by default not encrypted due to performance reasons or different other reasons. So you can have encryption config to encrypt the HTTCD key value data store, which is there on the system, right? So just encrypt it. You can enable the encryption over there so that we have the secrets that are stored and the data that's stored in the HTTP server is sort of like encrypted. So the config maps, for example, if you're storing, it's not recommended to use config maps to store secrets. Instead, prefer Kubernetes secrets. But in case if you're storing passwords or config maps and those are traveling through network, there's a risk. So in that context, I would say it equally important to encrypt the data at rest as well when you take care of upgrading to TLS and encrypting the communication, right? Authentication and authorization. So Kubernetes basically has two types of users, service account and normal users. So for service accounts, Kubernetes manages the life cycle of certificates and it takes care of everything. But for normal user accounts, it's basically Kubernetes assumes that you have out of the cluster authentication service or method that you are using for the normal users. So make sure you are using the strong authentication methods like OIDC or bearer tokens or signed certificates, right? So that will be adding additional, I would say, security when you deal with the authentication and authorization stuff. With Kubernetes 1.6 and above, all the requests which are sort of like not validated by the existing authentication methods are sort of like deemed to be considered as anonymous requests. So anonymous request is something which basically has, I would say, certain sort of access, like metrics, you can say health probes, liveliness, readiness. So such sort of metrics can be accessed by the anonymous user. Any unauthenticated request which is deemed as an anonymous request has a username of like system I would say unauthenticated as a group and system anonymous as the user for that request, right? In case if you have a sort of misconfiguration on your system, you might end up providing access to the sensitive data to the anonymous user. So if there is no requirement of, there is no such purpose of having anonymous user access on the system, you can straightforward disable it. You can use the flag in the Kube API server or just pass it to the kubelet runtime and you can disable the anonymous access over there, which is by default enabled in the recent versions of Kubernetes. RBAC, which is role-based access control. This is an important player when it comes to authentication and authorization in terms of creating boundaries over there. So we are limiting access to critical cluster resources like say secrets or pods or whatever it is to the users. So it basically operates on roles. We have default roles. Kubernetes also provide default roles like view, edit, and admin, cluster admin, right? And user can also create a custom roles as per their requirement. How does a role look like? This is a basic example of role where you can see the resource here is pod and what all permissions are provided, the verbs you can say here. The verbs are like get, watch, list. So what does it mean? If a user creates this policy and role, I would say, and it's assigned to a new user or existing user, that user will be able to get, list, and watch pods on the namespace which is there here. It is role, right? Likewise, if you just replace kind role to kind cluster role and you provide the verbs over there, the resources, it could be instead of pod, it could be the secret, right? So the user will be able to get, list, view secrets at a cluster level. So there's no restriction over there. And in most of the cases, what developers or newbies might do is like they just put star in the verbs here instead of get, watch, list, or different actions like update, upgrade. They just mention star because my life is easy. I've mentioned star and I've granted everything. That's bad practice. So instead of just having wild character over there, prefer having dedicated roles, permissions, what you want the user to execute on the system. So this is how you can create roles and roles and cluster roles and further bind that to the users. We call it like role binding and cluster role binding, right? Audit logging. Before I begin with this here, let me mention that no matter if you have the world's best logging solution on your system, on your cluster, it's useless if the logs are not monitored, right? It's dumping everything, but it's not examined. If the logs are not examined, it's useless. So yeah, by default, audit logging is disabled. You can enable it. There are different, I would say, log levels provided. It's basically starting from top to bottom. It increases the verbosity, right? Be mindful if you are going with request response, because that's the highest verbose logs. That's something you can achieve from it. There is a risk associated, like you might get some sensitive information dumped to your log files. Like it could be base64 encoded passwords, any other sensitive information, because it's more verbose, right? I would suggest start with metadata level and see if it meets your requirement. You can slowly increase the log levels as per your requirement and experiment accordingly. So as I said, like there are chances of sensitive information being dumped over there. It's suggested, it's recommended that when you store the logs, it is good practice to store logs external to the customer cluster. You encrypt the logs at rest as well, right? Just not, I would say, okay, I've generated the logs, I'm storing it over there. What if there's any sensitive information over there and someone has access to that log outside the cluster? Could be dangerous. The user can get sensitive information from the logs over there. So it's important to encrypt at rest as well. Collect logs from different, I would say, metrics, like cluster metrics will be the application logs, pod logs, API logs. And Kubernetes by default doesn't come with inbuilt observability solution. However, it does provide the API endpoints to integrate observability solutions. When I say like logging, or it could be monitoring, tracing, right? The open source solution like Grafana, Prometheus, whatever it is. So you can have them integrated with Kubernetes, but there are no inbuilt such solutions. So yeah. These are a few, I would say, events that an administrator must monitor or account for, like network traffic, volume mount actions. It could be the privilege changes, playing with RBAC, right? If you have changes anything with RBAC, resource consumption. So these are some sort of like basic events that an administrator could consider when auditing, monitor these events. Do we have enough time to cover this last slide, basically, or 1 minute, and maybe I can quickly touch through? So these are very generic practices, like make sure you are having your security patches or update levels up to date on your systems, just to mitigate any risk, known risk that's already fixed by the upstream or the vendor, and you're just patching your systems, right? Perform periodic vulnerability scans, penetration testing in your environment, just to explore and get awareness of any risk which is there on your systems, right? Like SAST or some sort of scannings that you can have on your system. Uninstall any unused component. For instance, your application is using some Python module or some Node.js module which is not maintained since last 3 years, 4 years. The maintainer had it on their radar, but now they have stopped the project. But your application is still using it, right? So it's a risk. It's unmaintained component. If tomorrow there's a risk for that component, it will not be fixed. So ensure that you find better alternatives for the components. Those are outdated, deprecated in the upstream, it's not being used. Find the alternative and upgrade to the correct alternatives, right? The last one is like, those are mostly for image building and configuring stuff. I would say start from the scratch and bare minimal image, because if you just go with the readily available image, there could be some components in the base image, some packages in the base image that you will not be using in the near future, right? So it's just lying over there. It's increasing the maintenance overhead. Tomorrow there will be a vulnerability, and if you're not respinning the image, if not upgrading the image, it is a risk that you are still continuing to use it. So it's best suggested that to build the image from scratch or use the bare minimal. Only use the dependencies that are required for the functionality. Always pull the images from the private stuff, and the other part is like self-explanatory, I would say. Scanning it and configuring to run as unprivileged user. So on the second slide that we saw, run as user and run as non-root, those are on the runtime changes. So if at the time of image building, if it's declared straightforward, like, okay, this is something that should be running with this user ID or something else, the containers will be adhering to that and no runtime changes will be required. So yeah, that's most of it. Thank you for listening. I can open up for questions if you have any. Pardon? You can use open source. I would suggest, at this platform, I can suggest you the Trevi and Claire is something you can go with initially. There are other commercial tools as well, But speaking about open source tools, Trivi and Claire, you can give it a try. GoSec is also there. If you have the repository handy, you can scan it. GoSec will be helpful because most of the Kubernetes operators are Golang based, right? And GoSec is something handy over there.